Hello everyone, welcome back to my AI/ML series, myself Arnab Kundu. In the last video, I worked on SVM classification model, and today I will look at another very important model in machine learning, logistic regression, right? Logistic regression model is used for classification problem like yes or no, true or false, survive or not survive, spam or not spam, disease found or not, like that, right? The logistic function or sigmoid function is used in logistic regression. Logistic function is a specific sigmoid function. Okay, today I will use Titanic Dataset, which is available in Seaborn module, right? Titanic Dataset is based on RMS Titanic disaster. Okay, the RMS Titanic disasters happened in 1912. So go to the computer screen. Step by step I will explore logistic regression in details. So let's dive in. Hello friends, welcome to my channel Technical Arquen, and today I will discuss logistic regression, which is one of the popular model in machine learning, right? Don't be confused by the name, even though it is called regression, but this model is actually used for classification tasks, right? Logistic or sigmoid function is used in logistic regression. Logistic function is a specific sigmoid function. In logistic regression, the logistic function is defined as 1 by 1 plus e to the power minus z, where z is equal to m dot x plus c. M is the weight and c is the bias, right? Now we should know what is logistic regression. Logistic regression is a supervised machine learning algorithm that accomplishes binary classification tasks by predicting the probability of an outcome, event or observation, right? Logistic regression is a classification algorithm, not regression, right? And don't be confused by the name regression. Okay, why? Because this model applies sigmoid or logistic function on the top of the linear equation y equal to mx plus c, right? It predicts the probability that an input belongs to a class, uses the sigmoid or logistic function to map values between 0 and 1. Okay, because in logistic regression, the logistic or sigmoid function is defined as 1 by 1 plus e to the power minus z, right? And this converts the output into a probability range between 0 to 1, right? Best suited for binary classification like yes or no, survived or not survived, spam or not spam, right? Now talk about why logistic regression. Linear regression fails for classification because outcome can be less than 0 or greater than 1, right? Logistic regression outputs probabilities easy to classify and range between 0 to 1, right? It applies a sigmoid or logistic function on top of the linear equation. So the logistic function is a specific sigmoid function 1 by 1 plus e to the power minus z, where z equal to m dot x plus c, m is the weight and c is the bias, right? Widely used in medical diagnosis, credit scoring, fraud detection, Titanic survival prediction, right? Now we talk about the key features of logistic regression. Supervised learning algorithm, it is used when the dataset is leveled. Okay, so what is level data I have already described in my earlier video, so I will put all the earlier videos link in this video description, you can check it out, right? Classification model, unlike linear regression, continuous output is concerned. Logistic regression predicts discrete outcomes, 0 or 1, true or false, like that. Okay, Sigmoid or logistic function uses the sigmoid curve to map values between 0 and 1,
representing probabilities,
and the curve looks like S, right? So just see, it's look like an S later. Okay, probability based, the output is the probability of belonging to a particular class. Example, probability of having a disease or not, survive or not survive, like that. Okay, so now I will go inside my Google Colab workspace and I will describe step by step logistic regression model. Okay,
now I am
already inside the Google Colab and the code for logistic regression model is concerned,
already written into there,
and we put that file name logisticregression.ipynb. okay, and we already know for machine learning is concerned, so code steps are as follows. Like, at first the step is import libraries, means import the modules. So we use the numpy y for the numerical computation, pandas for data manipulation and analysis, seaborn, matplotlib and pyplot for visualize the result or outcome, and sklearn is needed for do the machine learning tasks, right? And after that, the second step, we load the dataset. So here I am using Titanic Dataset, which is based on RMS Titanic disasters, and these disasters happened in 1912, and this dataset actually available within the seaborn module. This dataset contains 891 passengers detail, have 15
features,
and have the outcomes or the output value is 2, survived or not survived. Survived is represented by class 1 and not survived represented by class 0, right? And so we just load the dataset and then we select features and target, and what happened, out of 15 features we just kept only the 5 features. The first 4 features for the input feature is concerned, and the last feature is taken as an output value. Okay, and what happened is given in a double square bracket for to make it as a data frame, usually as a 2D array. Okay, and also we use here a drop na, this method. Why? Because we drop
those rows
which have some missing value. Okay, because it's a big data set, have 891 rows and 15 columns, so those values are missing, means those rows values are missing, just ignore it or drop that rows. So that's why you're using this drop na, this method here. Okay, and after we convert the categorical variable into numeric, means we converted the categorical data like sex and class into a numerical value. So sex for male is female is concerned, so for sex category the male is mapped to 0 and female is mapped to 1, and same way the class category, the first class, second class and the third class are there. So first class is mapped to 1, numeric 1, the second class is mapped to numeric 2, and third class is mapped to numeric 3. Okay, so that's why we do that conversion, and after we just take these input features within this capital X and the output value in Y. So for input feature is concerned, it's taken as a data frame because usually a 2D array, and for this output value is a series, that's why it's a 1D array. Okay, and then we use the train underscore test underscore split, this function. Why? For splitting the data into 2 parts, one for training and another for testing. Training is 70%, testing is 30%, because we send the argument test underscore size equal to 0.3, and x underscore train for input features for training, x underscore test input feature for testing. Same way y underscore train output value for training and y underscore test output value for testing. and we send argument capital X and Y, and also set the splitting size 70/30 training and testing is concerned, and then we set random underscore state equal to 42. Why? Because ensure the productivity of the result. Okay, then we create a logistic regression model, and we create a logistic regression classifier object. Okay, and here we send a argument max underscore iter equal to 200. Why? Actually, by default scikit-learn uses an optimization algorithm called iterative solver. Okay, and solver improves the model step by step until finds the best parameters. So algorithm will try up to 200 steps to find the best model parameters. So that's why we are using here max underscore iter equal to 200. Okay, and after that we use this fit method for the train the model. So we are train the model using the training dataset, the input features for training and the output values for the training. Okay, and after that we predict from the model, and we send as an argument
Unseen input feature for testing.
and what will be the output. Okay, then we evaluate the model using these three different function: confusion underscore matrix, classification underscore report, accuracy underscore score. And for each and every
Functions.
send two arguments. One is a true output and another is a predicted output. True output, predicted output. True output, predicted output. So compare these two results and it will evaluate,
How the model will perform.
right? So this is the evaluation part for this logistic regression model is concerned. Then we visualize our result or output. Okay, we are plotting the 2D graph in a bar chart is concerned. One plot means plot survival by sex, and another plot survival by passenger class. Means sex means male, female, this category, and passenger class means first class, second class, third class. So in that case we are using this method, this is a C-bound method, the count plot, and put the title Titanic survival by sex, and after show the bar chart. Same way use for the plot survival by passenger class, title given Titanic survival by passenger class, and also show the bar chart. So if you execute this code, just press this button. So it will take some times to generate the result because it train, then evaluate, and then will give the output for the evaluation function is concerned, and then it will draw the 2D graph in bar chart is concerned. So at first it shows the confusion matrix output.
Actual not survived. Actual survived.
This column is predicted not survived, and this column is predicted survived. So this position
102 means
102 passengers were correctly predicted as did not survived. Okay, and this position 63 means 63 passengers were correctly predicted as survived, but 24 passengers were wrongly predicted as survived, and 26 passengers were wrongly predicted as did not survived. Okay, so there have some misclassification is also present within this confusion matrix. Okay, and after that the classification report is given. So precision, recall, F1 score, support. Okay, and after that we get the accuracy result 0.76744. So if we convert it into percentage, so it will be like that 76.74%. That means this model is doing fairly well, but it is not perfect because some misclassifications still happen. Okay, because that's why the accuracy is 76.74%. Okay, and now this is the first bar chart on Titanic survival by sex. So this orange color bar is represented by the survived, the blue color represent the not survived. So here we can conclude that the higher survival for female. So this first bar chart shows higher survival for female than the male candidate, and the second bar chart is concerned, so it will
tell the
higher survival in the first class and lower in the third class, because the not survival case is more in the third class, and same way the more not survival
case is
higher in the male class. Okay, so I hope you have understood how logistic regression model works and how it
classifies.
is not actually the regression model, it is actually a classification model, because the logistic or sigmoid function is applied here. Now this function converts output into a probability range between 0 to 1. If you like this video, please like it. If you have some doubts for today's video is concerned, just write in the comment section. I will try to solve this problem. Those who are still not subscribed my channel, please subscribe it. Keep watching Technical Arcane for more video today up to this. Thank you and bye bye.